Okay, welcome to physics. I'm Fala Nyandemo, and I want to present some lessons that will enable anyone that loves physics or that want to love physics or that have the passion. I want to be taking tests in physics like WAS, and we have passion to do physics in high areas at college. Okay, this is physics, basic principles and laws in physics. I would like to present lesson 1 today. Sir Isaac Newton's laws of motion. He stated 3 laws. Go straight to the laws. Law 1 is Newton's first law of motion. Newton's first law of motion. And what this law states? This law states that this law states that a body at rest will remain at rest, or a body in motion will continue its motion. So a body at rest states that a body at rest will remain at rest. A body in motion will continue moving in motion unless acted on by an external unbalanced force. Unless acted upon by an external unbalanced force. In summary, this law states that a body at rest will remain at rest, and that in motion will continue its state of motion unless acted upon by an external unbalanced force. This law is also referred to as this law is also referred to as the law of inertia. And what is inertia? Inertia is defined as a tendency of a body to remain at rest or uniform motion in a straight line unless acted upon by external force. The tendency of a body to be at rest or to be in motion unless an unbalanced force acts on it. That is Sir Isaac Newton's first law of motion. Let's go to his second law of motion. The second law of motion, as stated by Sir Isaac Newton. Newton's second law of motion. This law states that the force acts on the body, the body will continue to move in the motion, continue to move in the direction of the force. It will continue its motion in the direction of the applied force. So in that case, he said that force is directly proportional to acceleration. If the body is at rest, apply a force on it, and the body moves, it will move in the direction of the acceleration of this body. So the force acted on this body will move in the direction of the acceleration. So force is directly proportional to acceleration. That's what he said. Perfectly correct. This law states that in words, This law states that when a force acts on a body, the force acts on a body, the body will accelerate in the direction of the force. If a force acts on a body, the body will accelerate in the direction of the force. Force is directly proportional to acceleration. F is equals to ma, or from here F is equals to certain constant K and A. Or in another way, or F is directly proportional to mass, yes, so on. So the formula ends in this form. F is equals to ma. Okay, F is equals to ma. Force is equals to mass times acceleration. So F stands for force, m stands for mass, and A stands for acceleration. Force, mass, and acceleration. So where F is equals to the force act on the body, m is equals to the mass of the body, and the A is equals to acceleration. That's what Sir Isaac Newton gave to us as a second law of motion. It is applicable in many ways. So this law can be stated in another way as this. Now the force is directly proportional to the change in momentum of a body. Force is directly proportional, or force is directly proportional to change in momentum of a body. Momentum is mass times velocity. So change in momentum, the rate of change in momentum. So if it's proportional to this one, the rate of change in momentum, then therefore F is equals to delta P over T, where delta P is equals to change in momentum. So force is directly proportional to the rate of change in momentum. That's another way of stating Sir Isaac Newton's second law of motion. A force that's acted upon the body, that's applied on the body, is directly proportional to the rate of change in momentum of the body. So now, from this formula, you can obtain, you can expand this formula. Change in momentum means mass times velocity. Number one, the rate of change in momentum. The rate of change in momentum. Also, F is equals to mass. Change in velocity here. Here you have change in velocity. Okay, it can be change in velocity, which means V minus U all over T. That's what into change in momentum. That simply means you have change in velocity here. Here you have change in velocity, delta V.